In this video, we are going to discuss about what is supervised learning in machine learning and what are the different types of supervised learning in machine learning and what are the several keywords which are used in machine learning. So to begin with, the basic definition of supervised machine learning is that in supervised machine learning, the machine learns under the guidance of a teacher and guided set of data is fed to the machine. That means machine is being fed a labeled data set. So teacher in this case is the training data. Now there are different types of supervised learning in machine learning, and those two types are, firstly there is regression and the second type is classification. So these are the two types of supervised learning in machine learning. Those are regression and classification. And firstly, we will be discussing about regression and then implement several examples of that. So regression is a type of supervised machine learning, and it is used to predict the relationship between the dependent variable and the given independent variable. That means it establishes a relationship between dependent and independent variable. Now the basic relationship which comes to your mind about dependent and the independent variable is the equation of the line, that is y is equals to mx plus c. So in this, x is an independent variable and y is actually a dependent variable, that is depending on x. Such type of dependency is generated using the regression type of machine learning. Now there are several types of regression also, such as linear regression, logistic regression, polynomial regression, stepwise, and many others such as ridge, lasso, and elastic net. So firstly, we are going to discuss about linear regression. That what do we mean by linear regression? Now linear regression is probably the simplest approach for statistical learning. It is good to start point in more advanced approaches. And in fact, many fancy statistical learning techniques can be seen as an extension of linear regression. Therefore, an understanding of the simple model will build a good base for moving on more complex approaches. Now, the output type of this linear regression can be continuous and mostly a number. And what are we going to find in this particular linear regression? Best fit line. And how do we evaluate? We evaluate by mean square error. So these are the several things. Now I am just going to show a simple plotting of, let's say, this particular line only. Y is here and here is x. So these are the dependent variables and this is the independent variable. And this is the line which is plotted and there are several data points. So these are actually data points. And this is the line of regression. Now we can estimate the coefficient also. That means we have assumed the linear regression as expressed as y is equals to mx plus c. That can be also written as y equals to ax plus b. So b is the constant, or sometimes known as bias also, or in the line equation we have studied that this is the intercept of the line. Now A is the coefficient or the weight in which the x depends. So x is the predictor or the independent variable, and y is the predicted and dependent variable. Different values of bias of the coefficient of A and B given in different lines, and now we see that how error is calculated. So for the calculation of error, we actually do predicted value minus true value. This is we do for the error calculation. And predicted value, that is, we have two sets of data here. The first is the trained set and the last is the test set. So while testing the data, whatever value is generated, output is generated, that comes to the predicted value, and the true value which we have for the original data set, that is subtracted, and then we calculate the errors. So what we do here is we minimize summation of predicted minus the true value square. Now the question arises is why it is squared. We square the error because the prediction can be either above or below the true value. Here you can see that the predicted data points can be either above or below the true value of the line of regression. Now, if we do not square the error, the sum of error could decrease because of the negative differences and not because of the model is a good fit. So to make the model good fit, we square the error. Also, squaring the error penalizes large differences, so minimizing the square error guarantees a better model. And next we are going to learn about a new term, that is a gradient descent. So gradient descent, now to update A and B values in order to reduce the cost function and achieving the best fit line of the model, we use the gradient descent. The idea is to start with the random A and B values and then iteratively updating the values to reach the minimum cost. That means we have the equation like this: y is equals to ax plus b. So randomly, by changing the values of a and b, we generate a gradient descent so that we reach the minimum cost. So these are all about the basics of the linear regression, and next we are going to operate on a data set, and you can download the data set for operation, that is a salaries.csv kind of data will be generated. This is the data, years, experience and salary, and this we will use for doing several commands of simple linear regression in our upcoming video.